Okay. Welcome everybody to this workshop on cloud databases. We'll understand today, friends, databases in cloud. Okay. Before we get started, let me introduce myself, friends. My name is Roshan. I am with ESA. Been taking up trainings in ESA from last 6 years. I take up SRE, Site Reliability Engineering course, Cloud Performance Engineering and DevOps course with in ESA. On my IT experience, I have 18 years of experience. I started my career as a Java developer, and then I have been in performance engineering from quite some time. I have been in various other SUS, Linux admin. Currently, I'm working as a principal SRE with one of the reputed giants of the retail world. I have been DevOps and SRE consultant, and I have worked on multiple cloud, uh, be it AWS, Azure, GCP, Oracle, four cloud I have worked on. Okay, so friends, we are here. So the agenda for today's discussion, friends, that we will understand about cloud databases. We all know about database. Any website application that we see around needs to have data, right? We cannot have our application up and running without data. And to access the data in real time, we need a database, right? Uh, be it if you go to Flipkart page or Amazon.com page, when we search for the product, we need data to be stored, all the product information. When we complete our order, our orders. Mhm. Okay. Requesting everybody to be on mute. Um, when we complete our orders get stored in a database. And there are various kinds of database. Right? We have not just the relational database. Depending on the data, type of data we are storing, we have a lot of type of databases, relational, non-relational, right? So just to get an understanding of my audience here, friends, uh, may I know what all different databases you have worked upon or you're working on? Use the chat option, friends, or you can unmute yourself. It's fine. Let's make the session interactive. We'll have definitely some learning session here. Yeah, I would like to know your experience on database. Is it relational, non-relational? If it's relational, which one? MySQL, Oracle, DB2, SQL Server, or you have been working on Mongo, Cassandra, DynamoDB, in-memory database. Okay, I've started getting responses. Okay, SAC. Okay, I'm getting Oracle, Nashima, Oracle, Sai Krishna, SQL Server. Okay, all these type of relational database, right? For relational database, we store a typical kind of information. For example, let's say if I ask you, friends, the for a retail website, the product description page, right? If I go to a retail, let's say an application, let's say I go to Flipkart page, right? And if we talk about all the product information, we need a database, right, to store all the product information. Let's say if I go to this monitor, right, we have so many monitors. And if I just go in one of the monitors, we have so much of data being stored, be it specifications, the description, and look at the specifications of the information we have, ratings, reviews, so many things related to the product. Do you think we can store this information in a relational database? Do you think so? How many of you think yes? Friends, yes or no, I need. That's all. All I need is your current understanding. Don't worry about right or wrong. No response. Please help me understand, friends, your thoughts. Okay, let me help you here. Now, this is monitor page. And if I go, I can search for some other item. I can go to some, let's say, baby kids. And if I want to get the certs, do you think the specifications, see, for a relational database, we store in a table where we have a column and like columns, and then we insert rows, the records. Do you think the description of a monitor versus the description of a cert would be same? Or do you think can I fit those information in this in a table, same table? Do you think the column is going to be the same? The Let's say I have specifications here, right? Specifications like this, or I have brand, model name, series. Do you think I'm going to find this information? Is this information relevant for the cert product? Do you think so? No, right? Totally different product. Totally different product. So we cannot fit this. Now, if I ask you employees in a company, can I store the information of all the employees in a table? Because every employee will have the same characteristic, the columns, right? The name, first name, last name, date of birth, place, team, different things, right? I can store that information in a table. But this kind of information I cannot store in a table. We need to store in document database. I'm not sure how many of you heard about MongoDB. In MongoDB, we store the information, all the records in document, JSON format. So depending on the data, your database selection is different. Everybody, right? Uh, we all know about monitoring tools that we have when we monitor the system? We have monitoring tools like Dynatrace, App Dynamics, New Relic, Datadog, Prometheus, Grafana, Elastic Stack. Are we aware of those tools, friends? Any tool monitoring, the importance of monitoring. Do we understand that?
Yes.
Right now, what we do there, think about it. We store a lot of information there, the information from all the data sources, CPU, memory, response time, throughput, errors, status code. If it's a database, disk latency, write latency, read latency, connection. We store so much of information and we keep storing every 30 seconds. We need a database there also. So what type of database is that? Have you thought about it? Don't you think, don't say that we don't need database there. We need database, definitely. We need historical data. What happened 2 months back? What was the CPU? What was the CPU trend? What was the in response time trend over the months? What happened 2 months back? How much status code, response time, CPU are the 2 months back? We need the information. So where this information is coming from? That information is coming from the database. So we need to store metrics kind of information in a database. The logs, application logs, we need to store in a database. So we have we have the requirement of depending on the data, there's a requirement to store the information. And I cannot just fit everywhere relational database because we just know that. No, we have options. We have got multiple options. And cloud offers that. We have various database because depending on the data. Because if I talk about the metrics, we need a time series database. I told you about document database like MongoDB, where we store this kind of information. Now to store metrics, we need a time series database. I'm not sure how many of you heard about Prometheus or InfluxDB. Both these databases are time series database. They are optimized. These databases are optimized to store metrics information. Metrics, when I say the x-axis time, y-axis value. So my point is that depending on the data, the database selection is very important criteria for any architecture. Everybody with me till here?
Yes.
Yes.
Now, what about the cloud databases? Do we have options in the cloud? Let's say I'm showing you friends AWS. I'm not sure how many of you comfortable or knows about this screen. Okay. How many of you are familiar with this screen? May I know? Just yes or no. I just need so that I can take the discussion accordingly. How many are familiar with this AWS console? At least do we understand cloud? Yes or no, friends, quickly in the chat. I'm not expecting a big full knowledge. Basic understanding is fine for me as of now. Quick response will be helpful. Okay, I'm getting yes, 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 yes. Okay, Alexandra says no. Okay. So friends, okay. Before I get started, friends, let me ask you one more question. What's your friends the skill? I just need. I forgot to ask you an introduction so that I can take up the discussion accordingly. Friends, I need you to quickly put um, your core skill and years of experience. Let's say if you are a performance tester engineer, just type performance testing in performance engineering and years of experience. That would be helpful for me so that I can understand. Um, or if you're an automation engineer, just type automation engineer. If you're into DevOps, type DevOps. If you're into developer, just type developer. Just I need quickly, friends, from you, all of you, so that I can take this discussion accordingly. Okay. I see performance engineer, 9 years, 7.5 years, 6 years, 8 years, 9 years. So friends, quickly, friends, this will help you spend. I need everybody who has joined to have some learning session with me. I want you to feel good, to learn something. I don't want to waste anybody's time. I want you to have learn something in this in 1 hour. And I'm going to make sure that it happens. Okay. That's on me. But I need some basic understanding from all of you so that I can take it. Okay, friends, I am going to consider most of us are performance testers, engineers here. Okay, friends, if you are a performance tester engineer working in IT from last 5, 6 years, and if you do not know cloud, you are in a problematic situation, right? You need to upskill yourself. I would just say that you need to upskill yourself because we are deploying everything in the cloud. Every company is using cloud. Not everybody can afford to have on-premise system, and we should have a good understanding of cloud. Okay, I'm going to just ask one follow-up question. Do we understand core and RAM, cores and RAM, like the importance of core and RAM?
Yeah.
How much CPU, how much memory
Yes.
being utilized, right? That's very important. Because I have understood that not most of us are comfortable. Those who are not comfortable with cloud, they do not understand the importance of the CPU cores and the RAM. Very important. Okay. Now, friends, this is a cloud console. Most of you mentioned that you're comfortable with cloud, so I'm going to assume that you know this. It's a cloud console, normal AWS cloud console. You can get the similar console from Azure and GCP as well, other cloud providers. This is from AWS, and you can do a lot of stuff. Okay, what are the basic stuff we do in cloud, friends? Let's cloud, right? What are the basic stuff we do in cloud? What do we need from cloud? Quickly, what do we need from cloud?
Renting any required service from the cloud.
Now, what do we need? What actually you need?
The
Any
computing
VM,
power.
any VM.
Infrastructure like server,
Yeah,
data
perfect.
storage.
Perfect. Yes, VM. Yes. So friends, we use cloud because we want the servers to run my application, to support my user load, right? And I need a lot of them. I need storage, like Netflix needs. In Netflix is in cloud, AWS. They use a lot of storage because they have so much of content to store. Hotstar is in AWS. They use a lot of storage because they're in cloud. A lot of companies they are in AWS. So we need basically, I just keep it simple. We need server storage. Similarly, we have databases also. If you see here, if you come down, not just the servers. Yes, you can get the server. You can say, Roshan, I can get the server and I can install database on my own. Absolutely, yes. You can do that. But you will have to install databases. You will have to manage high availability. What would you do if that database goes down? Let's say, friends, you have a 3-tier application. Let's say you have a 3-tier application. Web server, app server, database server. I'll keep it like this, simple. Web server, don't go on the sizes, friends. I just intend to same size. Web server, let's say app server, and database server. What do you notice here? What is the specialty with the database I have done? What to be noticed? You can say, Roshan, you have just drawn database only one box. But for the web server, app server, you have done multiple databases, multiple web servers, multiple app servers. Yeah, if you're noticing that, absolutely right. I have done this purposefully. See, it's easy to scale. See, friends, when we hit any website, Flipkart, Amazon, the request from the load balancer, we hit the domain. From the domain, we hit the load balancer. From the load balancer, we hit the web server. From the web content is coming up. Then we hit the application server, and then eventually we hit the database where we get the information. Typical web application I'm talking about here. Right? Now, when it comes to the database, friends, for the web server, app server, we have multiple servers and we can auto scale also. If there is more load, I can set up some auto scaling. When more load comes in, web servers can auto scale, app server also can auto scale. One of the very important things, and why do we auto scale, friends? What is the main goal of auto scaling? Why do we need to scale auto scaling?
To handle the increased load.
Yeah, to handle the increased load, right? Yes. What is the advantage if I know the maximum load that's coming? Let's say I know the maximum load which is coming. I can configure that many servers. Why do I need to auto scale? Why do I need to auto scale them?
If there is
During
sudden,
any special holidays, special days.
Okay, I'll just ask you a very specific question. I just want to check, right? Your understanding that we are all on the same page and we are thinking the same way. All I want. And then only I can make you understand better. That's why I'm asking this question. Okay, so let's give this. So let's say I have this situation. 7 a.m. to 8, 7 a.m. to 10 a.m. I have some load and I need 20 servers. 10 a.m. to 6 p.m. I have some load and 150 TPS. I need 15 servers. 6 p.m. to 11 p.m. 50 servers. 11 p.m. to 7 a.m. 5 servers. Let's say I have a various load workload modeling I'm doing. I have a throughout the day. I have a different load, and I'm giving you the service required. I'm going to ask you two questions. If we are in on-premise, if you really understand cloud, you should be able to answer this question. If you are in on-premise, how many servers will I create in on-premise to handle
50.
this load?
50 servers.
Okay. Santosh says 50. Do we all agree with Santosh?
I think 85, so 70, 80, 85, 90.
Okay, so Santosh and Aditya. Who agrees with Santosh? Who agrees with Aditya? If you are silent, friends, you're not even thinking.
No, it's 50, Roshan.
50 and
Yeah.
Aditya? Yes, absolutely right. If I have 50 servers, I can handle all the load throughout my day. Why do I need to add everything? 7 a.m. to 10 a.m. I had only 200 TPS and I required 20 servers. Why do I need to have 85 servers? So the maximum load, maximum server that I need is the 50 servers. That's the right answer. Now, is it wise to create 50 servers in the cloud all the time? In
No,
on-premise, I need 50 servers because see, in on-premise, we own everything. There is no advantage of auto scaling in cloud in on-premise because we are purchasing the server. But now tell me one thing: should we configure 50 servers all the time in cloud also?
no, I think 5 servers are enough and enable the auto scaling.
Do we all agree with Santosh?
Depend on the which infrastructure. Like if VMs are there, so I think we need to create the VMs. If it is
Yeah,
pod
VM only. I'm not complicating it. Okay, VM.
VMs, okay.
Server
I think
is a
VM we need
VM only.
yeah, server. So I think we need to create the VM here also, right?
My question was how many?
50.
All the time?
Yeah,
So
we
what is
need
the
to create.
difference? Then what is the difference between on-premise and cloud?
Yeah, we need to create the 50 servers, but we can upscale, stop and start according to our peak load
So
time.
who will do or start stop?
So we can run batch fetch files.
You're not complicating a lot because either your understanding is not clear. We have auto scaling option in cloud. I would start with 5-10 servers and let the load increase. Let the server auto scale depending on the requirement. I can have some metric on CPU based on the CPU utilization. It will auto scale. It will scale down. Whatever it will happen, my load will be handled.
But
When the
you're talking
Hotstar,
about vertical scaling or horizontal scaling?
no, horizontal. It's not complicated. Vertical is not at all. When we talk about auto scaling, it's always horizontal.
Horizontal, okay.
When in Hotstar, so let's say T20 match is being telecasted. The match runs for only 3 hours, and during the match we have so many people watching, right? Streaming. We need more servers. So should we configure three server like more server only for 3 hours or 24 hours? Simple question. Cloud you pay as we use. That's the fundamental of cloud, friends. Why are we not getting it? I got a lot of responses from yes, I know cloud. But what is that you should understand it in cloud? We pay as we use. If we use more, you have to pay more. So if I just need more servers for 3 hours, why do I need to run the server for 24 hours, same number of servers when the load is not there? Are we on the same page? Friends, if you put yes,
Yeah.
no, I can help you better, right? If you have any question, please ask me. You're here to learn something. Please make the maximum use of it, friends. I have some experience I can share, right? Okay, good. Now, friends, that's the basic understanding of cloud, right? So we have auto scaling configuration. So I can do auto scaling. My point was I can do auto scaling on web servers. I can do auto scaling on app servers. Can we do auto scaling on database? If yes, what is the if yes, how? If no, why? Shall I treat databases the same way as web server, app server? Okay, I think I need to only help you here. Okay, I get it. See, friends, for databases, we cannot auto scale like web server, app server. Okay, because database, we store a lot of information. If I create multiple database, I need to replicate data. Think about it. If I go to Flipkart, I do an order, place the order ID gets saved in a database. And I have multiple instances of the database. So let's say when I complete the order, the data, my order ID gets stored here. Then what is the complication I will have when I have multiple database? That order ID has to be replicated to other database also. Yes or no? Because next time I request, if I want to search the order, the next time my order may go to this another database. And if the order ID does not exist, that's not good. So with database, friends, we cannot scale like web server or app server because we have lot of data. The data is being changing. For the app server, web server, we are not changing the data. We are not updating. We are not inserting. We are not deleting. Right? But for the database, we are doing it constantly. It is being updated. Yeah. For the select operation, is only select operation is there. It's fine. I can have multiple databases, but I don't do just select, right? We update. We insert records when we place the order. We modify. Sometimes we cancel the order. We modify the data. In the cart, sometimes we delete the data from the cart. So we delete operation also happens. So we cannot keep up with so many data changes every time and it will increase the cost. So with the database, I cannot create multiple instances of the database and operate. It's costly. So why not? So be better to create one big database, whatever you require, and make sure you have a standby database. If this database goes down, I can have the standby database also. I can have a standby database. If this database is down, all the requests will be routed to here. And the data from the standby, this is a primary database. This is my primary database, primary DB, serving the traffic actively. And this is the standby, just a standby. In case I have a problem with my primary database, this will be activated. But for this to get activated and be operational, I need to do synchronous replication. Immediately, this has to be synchronously replicated. It's a must thing, friends. It's a must that my primary database and my standby database is synchronously replicated. If not, the same problem will happen, which I just told you about the order ID. So this is how we maintain the availability of the database. But at a given point in time, only one primary database is what we require. And it's just standby. It will not be in action till this is active, up and running. Now,
How standby recognize whether the primary DB down or not?
now that can that from health check. We can do a continuously health check.
Okay.
You can write some script and keep on checking the health of the database. The same way, right? When we auto scale the load balance, on the web server, we have load balancer. On top of the web server, we have load balancer. If one of the web server is down, having problem, do you want the load balancer to divert the traffic to that problematic web server?
No.
How it is being done?
Health checks only.
Health check.
So here, standby DB is it doesn't have any data, right? Whichever primary DB
Every
having, only
data,
just a serving.
synchronous replication. It has every data what the primary has. It's a synchronous
Okay.
replication. Because immediately I need to route the traffic, and if I don't have the data, then what information will you give to the user?
Then in that case, standby DB also should have same configuration like primary DB, right?
Same, exactly.
Okay. Okay. Got it.
See what matters for the user, high availability. So this is how we make sure that the database is highly available, because for the web server we have got multiple instances. For the app server we have multiple instances. Even if one web server goes down, I will not have a problem. I can create another web server. If an app server goes down, I can create another app server, and I have got multiple instances. But if my primary is down, DB is down, I will have a downtime if I don't have a standby database. And downtime is a crime. We cannot do that downtime, right? We will lose revenue, business reputation. Think about it. You open Swiggy application and Swiggy is down, and Zomato is working fine, just fine. Will Swiggy lose the business or not? Able to understand, right? If Flipkart is down, if Amazon is down, and Flipkart is just having a good performance, no problem. People would tend to go towards Flipkart. Right? So we don't downtime you cannot have. It will have a long time impact in the users. And just synchronous replication. Immediately same data has to be there. If this database is getting updated, inserts, updates, deletes, it has to be replicated. Now, mostly we do two kinds of operations. In a database, friends, we perform two kinds of operation. Either you read or you write. Do we all agree? Either you read data or we write data. Is there any more operation you do? When I say read, select queries. Write, it could be update, insert, delete, write. So either you read data or write data. And whenever you're writing the data, it has to be replicated here. When you're reading the data, it's absolutely fine, no problem. Yes. So now you can say, go ahead.
So replication, you are saying, right? So replication means both databases are always continuously active.
See, when I'm saying replication, what is replication means? The copy. Replication is nothing but the copy. Replicate.
It's a
Copy.
copy, but the database is so both the databases will be online always continuously, and they are replicating, right? You're saying.
See, only this is active. Application server will only know about primary database. Application server, yeah, both will be running absolutely fine. But all the application server will only know about a primary DB. This is just a standby. It is active, always up and running, but it will not serve any traffic. No request will come here. You got your point?
Yeah, I got it.
It's all about where the request is coming, right? Now, friends, you can say that, okay, I can create EC2 instance, I can create a server, and I can install database on my own. Yes, you can do that. If you do that, you will have to manage everything. You will have to install database. You will have to make sure you have taken care of high availability. you are taking care of storage auto scaling, because this disk storage will not be a problem. So you will have to manage everything if you go on your own. So I'll give you one example, friends. Let's say I have a three scenario. In one scenario, friends, we are setting up the database in on-premise infrastructure. In on-premise, we don't get the server. We have to do virtualization, and then we can get. So as in on-premise, this is the role of a DBA. The DBA has to perform a lot of activities. DBA have to do the virtualization. It will do the server maintenance, rack and stack maintenance through virtualization. It will get a server. It will install OS. On top of that, you install database. You take care of database backup. You take care of availability. You take care of scaling, and you optimize the code. This is the role of a DBA in on-premise. Now, the moment you move to cloud, you have got two options. You get the server and manage on your own. When you go to the cloud, you got your server and you are taking your own the rest of the activities. Okay, till OS installation taken care by the cloud. Right? If you can create a VM, those things are being done by the cloud. Now, as a DBA in the cloud, when you go with the virtual machine, okay, do we understand virtual machine? Do we understand this graph? If you do not understand, please do let me know, because you will not like it if you will not understand this. Whatever I'm telling, if you don't understand, if you are in cloud, till OS installation is taken care by the cloud. Do we all understand this? Are we on the same page? Yes or no?
Yes.
Somewhat no. Can you explain?
Means, okay, so you have not created a virtual machine in the cloud, VM in the cloud, Santosh?
Yeah, cloud created EC2 instance.
EC2. That's what. So when you got EC2, are you creating it or cloud is helping you create?
I think cloud is helping. Just we are
We are
actioning that
just
EC2.
selecting the options, right? We are just selecting
Yes.
OS, CPU, memory, and cloud is helping us create. Same thing.
Yes.
I'm getting the server here. Cloud is this is the cloud responsibility. And I got the server from the cloud and I'm installing the database in that server. Here, everybody? If you are not understanding this, basically you do not know cloud, friends. You should definitely know cloud. Okay. We have a service called EC2. I can go to EC2 and I can create a server, 4 core, 8 core. I can go to instances and I can just select options. I don't see if when I'm using cloud, I don't need to worry about virtualization. I don't need to worry about maintaining rack and stack. I don't need to worry about all those things as a user. All through the using the help of cloud, I'm getting the server. All I have to just select. I just need this operating system. I can get my 4 core, 8 core. I can get the core and the RAM. If I need 8 core, 32 GB RAM, I can get it. Right? I can just select all the options. I can create the instance. And that is what I'm trying to tell you. In the cloud, we're getting the server. And then on the server, we are installing the database and we are taking care of backup. We have to write script to take the backup. We have to take care of high availability. It will not, the whatever I'm showing you, it will not be, you will have to create this synchronous replication. You will have to do that. If you use server EC2 instance, you have to scale the storage and you have to optimize the code as a DBA. You have these many roles to do. In the on-premise, you had more role. In the cloud, you have slightly lesser role, but you have other activities. Okay. Are we good so far?
Yes.
Good. Those who are responding will have a good learning. Okay. If you're not understanding, you're just silent. I cannot help, friends. Okay. Now, will you like it if
I have a question. So you're saying you're installing the EC2 instance or Azure instance, everything in the cloud, we can create a VM and we can do everything, right? So what about the database also be installed on that VM only?
yeah,
The cloud or
that's what you get the
okay.
server, right?
Okay.
Why we need the server? To install our database.
But
What is the
directly we have an
purpose?
option in cloud, right, to choose
I
what
will come to
database.
that, Santosh. I'll come to that. That's the third option.
Okay,
I'll come
okay,
to that.
okay, okay.
So you're saying like you can have one main database on backup database, right?
Forget
Like
about that. Forget
okay.
about this. Forget about this. Whatever I have. First of all, you understand this or not?
Yeah, I
That
understood that.
you get the server and you install the database. And you will have to do two. You will have to everything. Now, when you are on your own, you are just taking help of AWS to get the server. That's all. You got the server from AWS and you will have to do rest of the activities. When I say rest of the activities, you will have to install database, two databases, one primary, one standby. You will have to install database in both. You have to take care of synchronous replication here. You have to do, you have to write script to auto scale the storage. You have to make sure like this is configured when this primary is down, the request goes to the standby database. Like everything as a DBA, we have to configure because you are just taking AWS help to get the server. That's all. Rest all the activities, whatever I told you, synchronous replication, health, monitoring, checking health check, and routing accordingly, routing the traffic to the standby, storage auto scaling, all these things, right? Database backup. You have to write some script to take the backup. High availability standby database, same thing. Storage auto scaling, app optimization. You have to do all these activities on your own. You got the server. That's all. In this scenario, yeah, you're good. Any question? Any question? Nazima, are you good so far?
Yeah, I'm good. So basically, you're saying just a bare bones server, we get it, install it. Also, that we need to install everything on the top of that. What else we need?
Right. Right. You have to do everything because you just asked this much from AWS. You got the server. Now, there's a third option. If I tell you there is a service in AWS like EC2, like how you got the server, there is a service in AWS, which if you use that service, you don't have to install, you don't have to take the backup, you don't have to worry about the backup, you don't have to worry about high availability, you don't have to worry about scaling. Will you like that kind of service? You don't have to take care of anything here. AWS will take care. Will you like that option? As a DBA or as a developer, as a cloud user, you have to just focus on the app optimization. Prop writing efficient queries, SQL tuning is all you need to do. Rest, all those mundane stuff will be taken care by the cloud. Will you like this kind of a service? That's the third option. That's cloud offers. See, why don't we see the role of a DBA nowadays? If you remember 10 years back, friends, you might have seen positions like Oracle DBA, Linux admin. Why don't you see such roles now? Because cloud has automated these steps. Earlier, we needed a dedicated person to install, manage my database, to take care of backup, to take care of availability, to install. We needed a dedicated person. Now, when we use cloud, these things are automated. We have a service in AWS, friends. Like how I showed you EC2, we have a service. Managed database, we call it. If let's say you worked on Oracle, right? This is a service database. If I go to the Oracle or RDS is the relational database, we have got multiple database options. We have memory database, which is like a Mongo database. We have key space like Cassandra, Elasticsearch like in-memory database. We have got multiple options in AWS. Okay. We have document DB. Document DB is nothing but the MongoDB. Uh, I just because you guys are comfortable with relational database, I'll show you this example. I go to RDS. and I can create a database. And just like EC2 instance, like how I selected the options, I will select it. Okay. In relational database, I have options. Which database you need? Let's say you selected, I need SQL Server or Oracle or MySQL, whatever. Selected, you select Oracle. Okay, which Oracle Enterprise Edition you need or Standard Edition 2 you need? Let's say Enterprise Edition I need. Okay. Do you have your own license or you want to purchase the license? You can also have the option of doing that. And you select databases, you give the name, you select your core and the RAM, how much core and the RAM you need, how much storage you need. Do you need auto scaling, storage auto scaling? I'll just check this option. Do you need multi-agent deployment for high availability? Yes or no? You just select that option. Where do you need? Do you need public access? Do you want to connect to other EC2 instance? You have monitoring, everything you have. Just select it, friends, and create it. You will have to pay some amount, but everything will be managed by the cloud. If I just create this, it will take 10 minutes and I will get up and running my database server with high availability done, storage auto scaling done, everything automated. That's managed database option. So this is on premise where you have to do a lot of stuff. This is the second option where you got just the EC2 instance and you are managing everything on your own. And there's a third option in the cloud where we have managed database. And if you use that, you have most of the tasks covered. Now, they cannot cover your query because that is on your part, right? You are writing the query. You have to take care of SQL tuning. Apart from that, other things are just automated. Your You can just let them know what is the backup frequency once in a day, once in a week, twice every hour. Just let let them know the backup. Just let them know high availability, that you need multi-agent deployment, storage autoscale. Just showed you. Just select all the options and create the database, and it's done. Configure with your app server, and it's up and running. This is where we are. People are using this. And think about it, friends. And most of you mentioned that, like, I don't, not everybody responded that you know cloud. Now you understand the importance of cloud. Cloud is automating stuff. On top of that, we have the Gen AI thing, which is automating in at other level. We have to be in pace with these automations to be relevant in the market. At least to be relevant. Forget about to be the best. To be relevant, we have to upskill whatever domain you are in. Performance tester, engineer, definitely you need to do that because your applications will be using this databases. You have to do work on that, these databases. If you say, I do not know cloud, I do not know EC2 instance, how will you do? I have got this. I have this. I'll ask this question. One of the roles as a performance engineer, friends, because I'll ask this question. I see most of 8, 9 is experience. I'm going to ask this question. Simple question. Let's say I'm doing capacity planning for an application that I'm going in prod or that's already in prod, and let's say I want to do capacity planning. How many servers would be required in prod? What do you think? Who is the right person in the company to know this? I would like to know from all of you. I need to know. I have an application which is live in prod. Okay, at least if it not even not in live in prod, I know the load in prod. I know the load in prod. Who should I ask the number of servers required to be configured in the prod? Who should we ask in the company? Who is the right team to ask to answer this question?
Architect.
Performance architect.
How architect will tell you? Tell me. What is how architect will tell you number of servers?
If it is a current application, like it is already in the prod, so by last year number and with current projections, we
No,
can.
that's fine. Then why
Yeah,
architect? Why architect?
yeah, performance engineer also can do. We can also do.
Who does the load testing? Who tests with prod load in the
Yeah,
organization?
we do.
A performance engineer or performance testing.
That's it, right? Simple answer. So architect is to architect the application, depending what would be the database, what would be the technology, whether to use Kafka or SQS or Kafka Stream, which database to use. That architect role. How many servers I need to scale up in prod? Performance engineers should know this. I have got this question, and not I people do not understand this, right? So we should do capacity planning. And let's say, friends, you do not know, and I got this very surprising. I know that not many of the performance engineer know that whether the application is deployed in the VM or it's the container. Now tell me one thing. If a performance engineer tester doesn't know whether the application is running in VM or in the container, what is the size of the container, what is the size of the VM, can they do capacity planning?
No.
But in most of the companies, they don't do any capacity. They do just do the performance testing and load testing, and that's it. They complete it. But
Exactly.
they
Now,
don't do
what is
the
the goal?
capacity.
Okay, Nashima, what is the goal of performance testing? Just to check application health, that's good. You could confirm, okay, with this load, but you do not know what is the load you're running, 1x, 2x of prod. With some random load, you ran the test, and let's say you got the response time of the transactions and you just published it. But what is the
No,
outcome?
no, random times not. Just like one thing is capturing the metrics on production to get the peak hour, and based on that only
Okay,
we
let's
are
say
going to
you
run the
did
load
with
test.
you did with 1x, same load as prod.
Yeah,
Let's say you did it. Then you are the right person, right, to know how many servers were configured when you run the test.
yeah.
If you're already running the prod load, then you are the most right person is you, performance tester. That how many servers were up and running when 1x load of prod was happening. So configure same number of servers, add some buffer, one or two servers, 5%, 10%, and that's it. So that's very surprising because I'm, I, we do not know where it's running. VM container, what is the size of the container, what is the size of the VM? We should know that, friends. That's all I'm trying to tell you, that we should think on these lines, right? One of the important things as a performance tester we can contribute, right, to do the capacity planning. That okay, uh, what is the prod load? How much we are testing? Are we testing half or one fourth of the load? Okay, how many servers we have, and as comparison to prod, and accordingly we should extrapolate and give the number, have some 10% buffer and give the numbers, and we should scale up auto scaling, so that in case of abrupt load increase we should have the correct number of servers comes up and running, be available to accommodate the extra load. And we can test not just the one server, we can test everything in the pipeline. We can also test the database. If we run with 1x load and we see database choking, we know, but we just it's not configured correctly, and we should recommend the right configurations in the database. We should know what is the CPU, memory, all the metrics, and so that's how we need to analyze our test and recommend. That's why we capture CPU memory, right? Okay, friends. So okay, I just got reminded of something, and very important. We should know that. So in the cloud, friends, we have this manage database option, and which is very much everything. A lot of activities are automated here, and we should leverage that. And we have fourth category also where we use database as a service. Mongo Atlas provides data. We have Snowflake provides data stacks. Cassandra provides a lot of database third party which provide database as a service. Like how we have monitoring as a service, like Dynatrace, App Dynamics, Datadog. They manage the infrastructure. We just use as a service like Salesforce or Workday. Same thing we have for the database also. The company started to do that also, and we don't need to worry about it. Just upload our data and let them know, and they scale. Right, friends? Basically, we require a lot of type of database. Okay, see, the first thing I was asking, right, the relational database, because you told I have worked on relational. You guys have mostly worked on relational database, but we have many other types of database. I gave you example of document database, like your MongoDB. I gave example of time series database, where we store metrics information. We have other kind of database also. We have key value pair, where we store information like key value. In-memory database, when the performance is degraded and we have when you have to cache something, right? We same concept. Why do we have RAM in our laptop, friends? Quickly, why do we have RAM in our laptop?
For better performance.
Yeah, because we cache the information, whatever we have in the disk, we cache. Right now, I have opened this presentation. Chrome, I have opened Teams, we have launched Notepad, I have opened. These things are open in the RAM. That's why we are having a smooth experience, right? If this information, but actually RAM, we don't persist the data. If I shut my laptop, whatever I have written in the uh, this paint, it will not be getting saved, right? This page is in the RAM. If I don't save this, it will not go to the disk. Think like disk is my database, and RAM is my in-memory database. So we have opened this. Whenever you open the application, it launches in the RAM, and that's why we get a good experience, good performance. Same thing when we go to retail website, they cache all the product information. How do you think they get displayed quickly? Go to Flipkart, go to a major and search for the product. It get displayed so quickly. How it happens? Because they have cached every detail. If I go here to search on any item, friends, they have cached everything. If I just want to search this, it gets loaded so quickly. How it is possible? Disk operation cannot be that fast because they have cached all the information, all the product information, they have cached it. And RAM is costlier than the disk, right? So we have in-memory database for that purpose. For the increasing performance, we do that. Right. So we have various kind of database, friends. Right.
What are the difference between RAM and in-memory?
The same thing, the same in the same context I was explaining it.
Okay.
So
Redis cache actually used for the faster retrievals.
correct, same as in memory. That's the Redis you use. AWS Elastic Cache we have. In open source, we have Hazelcast. So that's in memory. We cache information. So we basically, this information is stored in the disk, but we cache it. We store in an in-memory database because for the better experience, better performance. Same thing, we have RAM. Our operating system, our MS Paint, this page is stored is in the disk because we have installed everything in the disk, but we open the app, it opens in the RAM, in memory. RAM is nothing but the in memory. Why do we open in memory? Because we want to get a better experience. Whatever we do, it immediately gets populated there. If I just draw one line, immediately we see a line. Why? Because it's a memory. Memory is a fast. Read and write operations are very fast. IOPS are very fast. Input output per second is very fast in the RAM as compared to the disk. Disk is slower. Now earlier, if you remember 15-20 years back, we used to do HDD. We used to use HDD disk. And nowadays we use SSD. What is the advantage? SSD is fast, right? Our laptop gets
What
boots up
throughput?
fast, right? Earlier, if you remember, when we used HDD, our laptop was taking time to boot because the IOPS was not that good for the HDD disk. Able to understand this? This all depends on the IOPS. For the RAM, for the in-memory database, our IOPS are much faster than the disk, even SSD, much better than SSD. RAM is costlier, friends. You have, let's say, 250 GB of disk SSD versus 16 GB of RAM. Which is costlier? Check the price. Per GB, RAM is costlier. Yes or no? Yes? Am I making sense?
But while selecting database, okay, got it.
You can select any database irrespective of that. If you want to increase the performance, you have to cache the data so that you can avoid disk operation. The first information will be asked from the RAM.
Like in physical virtual machine, how RAM works in database, in memory works like that, right?
Exactly, same thing. That is same
Okay,
way I'm
got it.
talking about that, right?
Yep, got it.
Okay, friends. So that's about today's session. I hope we all learned something. Friends, if you want to learn, if you want to come up with some structural learning, right? I have something to show you. I am coming up with my new batch with ISA, and just go over it. If you think it makes sense, it'll add value to your career. Join with me. Um, this is SRE, we call it, and we take up cloud, we take up Linux. I also have seen most of the people are not comfortable with Linux. Fred, let me answer my one question. Why it's important to learn Linux? Okay, first of all, is it important to learn Linux or not? I just want to know your opinion. And why?
Yeah, it's important to learn because most of everything we do on the shell based on the building any kind of servers or anything on everything on the command line interface mostly.
99% of the application that we see around is hosted on Linux. Whatever application that you see, Ola, Uber, Facebook, Zomato, Swiggy, whatever you see around, right? It's all running on Linux, right? So friends, I have a course. I'll share this link with all of you. I have a demo session next weekend. I'll talk more about the course in the next weekend. I have shared the link to you. And in this course, friends, we talk about cloud and from scratch. I do not assume that there's no prerequisite of this session. I take it from scratch, zero level. We take up cloud, we take up Linux, and at good level, okay, at good
So
level.
cloud, you cover both AWS and Azure or only
No, no,
AWS?
no, 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 only AWS. One cloud. Just learn one cloud and you can learn others. AWS cloud, we talk about Linux, till cell scripting. We talk about SRE module, site reliability engineering, what is high availability, how do you take care of disaster recovery, how do you do incident management. We talk about architecture, monolithic and microservices architecture. We talk about Docker. We talk about Kubernetes, containers, right? We talk about Jenkins, CI/CD pipeline. How do we do that? Uh, we talked about a lot of AWS services, which helps us to make our application resilient and reliable. We talk about observability tool, Prometheus, Grafana, Elastic Stack, CloudWatch, Linux monitoring, Java performance engineering. We talk about Ansible and Terraform, right? And we share recorded session on core Java and Python. This course approximately takes 3 months to complete, and that's why my last batch was started in July. I am completing that batch July August time, and my next batch is starting next Saturday. Right? I've given the link. Feel free to attend the demo session and learn more about the course. If you think it adds value to you, get on with
How
me
many
in the
hours per
learning.
week?
Okay, we 2 days, Saturday, Sunday, this weekends, and we meet approximately 3 to 4 hours a week, Saturday, Sunday, 7:30 to 9:30, Saturday PM, 7:30 PM to 9:30 PM IST, Saturday and Sunday.
Only on weekends, right?
Weekends. That's correct.
Okay. Can we have this brochure? Whatever
I have just
syllabus.
shared the link.
Okay. Okay.
I have
Thank you.
shared the link in the chat. Okay. So friends, that's all. And this, whatever I just talked about is part of the course. And in the database cloud part, I just covered 20% of the syllabus, whatever we have. In the real class, I talk about, I show you create the database and I connect to the database. I see demonstration, I show you, I do a lot of stuff. So whatever I just showed you, what part of the same thing. We have database and was part of that thing, same thing we cover. So databases, I just talk about it uh, as part of the course. Okay. So that's all friends for today. I hope I made your 1 hour worth. Uh, any questions? Any questions? Any type of questions, friends? Okay, perfect. Thank you so much, everybody. I'll see you next weekend, next Saturday. Thank you so much.
Thank you.